All right, so these notes are going to be talking a lot about angles, specifically the two different types of measurements we have for angles, which is radians and degrees. And we're talking about this in the context of our study on trigonometry. So we're going to start off defining trigonometry, which is the branch of mathematics that studies relationships involving lengths and angles of triangles. So lengths and angles of triangles. All right, so an angle is generated by the rotation of two rays. So if you remember, maybe from any study of geometry, I know it's not in Math 2 now that I'm teaching Math 2, but maybe earlier on in a study of geometry, a ray looks like this. So that's a ray. So an angle is generated by the rotation of two rays that share a fixed endpoint. So you have two pieces to that angle. You have the initial side, which is the fixed ray, and you have the terminal side, which is the ray that rotates away from the initial side. Right, and believe it or not, the terminal side of an angle is actually really important in trig, and how we measure angles and how we think of angles and how we determine a positive angle versus a negative angle, and that sort of thing. So it's not something, you might not call it a ray, but in the way you think of it, the terminal side is actually really important. So a positive angle is actually measured counterclockwise. And we always start at the positive x-axis, which I'll show you in a second. And a negative angle is actually measured clockwise. And it all seems strange to start with, but there's a point where we will get very used to it. This is just how angles are measured specifically in math with trig, all right? So an angle with its vertex at the origin and its initial side along the positive x-axis, like I just said, is said to be in standard position. So this is like typical, this is what we always, we'd say this is kind of like normal. Okay, so what they've done is they've given you examples of what two different angles look like. So we're talking about this is a positive angle, this is a negative angle. In fact, I'm going to go ahead and kind of color coordinate these so we can picture this. I'm going to do red and green, not because we're talking Christmas, although we're getting close to having some festivity there. I'm just going to say that we're talking about positive versus negative. So we're going to talk this counterclockwise is where we get our positive angles from, and this clockwise is where we get our negative angles from. So right here, the positive x-axis right here is where we get our standard position from. So this is the positive x-axis right here. That is 0 degrees. Okay, so positive x-axis, that is 0 degrees. Right, so right here, again, positive x-axis is 0 degrees. So if you go up counterclockwise, you are measuring positive angles. If you go down clockwise, you are measuring negative angles. So you can see that this side right here is the initial side. That side is staying in that kind of standard position. The terminal side is the one that is moving, and that's how you're measuring the angle. So that terminal side is important because it's how you see how big the angle is. All right, if the terminal side of an angle in standard position is on one of the axes right here, we call it a quadrantal angle. So this is important because, like, if we had the terminal side right here, we would say, oh, this angle is in the fourth quadrant. This angle right here would be in the second quadrant. If you have a quadrantal angle, it's in neither the first or the second quadrant. It's kind of in between them. So it's kind of interesting to know that. That's just kind of a tidbit of information. I would maybe even go and highlight that because that is something, we got a little Rasta there. That is something that tends to confuse students as they go, well, what happens if it's right on the 90 line? Or if it's right over here on the 180 line, what quadrant is it in? And I'd be like, I don't know. Let's just say it's on the quadrant line and call it good. We're not going to say it's in any of the quadrants. All right, let's turn to the next page. I should actually look that up. I wonder if they consider it to be in one of the quadrants. Ms. Rice, you're a math teacher. You should know that. I know I should know that. I'll look it up. All right. Units for measuring angles. So we have two different units of measurement. One is degrees. A circle is divided into 360 equal degrees so that a right angle is 90. So let's go ahead and label this in the picture. So they showed you kind of here's the initial side, and then here is the terminal side, and they showed you if you measure it this way, that's 120 degrees. So here's the positive x-axis. Our standard position is 0 degrees. That's a 90-degree angle, so that's 90 degrees. Here's another 90-degree angle, so this is 180 degrees. Here's another 90-degree angle, so this is 270 degrees. And then we go back, we make a full circle, so this is 360 degrees. So when we get back there, we come full circle. 0 degrees and 360 degrees are considered to be in the same position. Now, radians are another type of measurement that we're going to learn when we talk about the context of trigonometry. And the radian measure of an angle in standard position is defined as the length of the corresponding arc on the unit circle. The length of the corresponding arc on the unit circle. So we know what an arc is. An arc is this piece out here. So the idea is the perimeter of the circle. And a unit circle is a circle whose radius is 1. A unit circle is a circle whose radius is 1. So when they labeled that this is -1, this is +1, this is 1, this is -1, they're telling you that the radius r equals 1. The radius of the circle equals 1. All right, so a unit circle is a circle of a radius 1 whose center is at the origin. The equation of a unit circle is x squared plus y squared equals 1. And you cannot graph that on a graphing calculator, but if you were to pull up Desmos on your phone or on a computer, you could graph x squared plus y squared equals 1, and you would see that it in fact is a circle and that it has a radius of 1. So the circumference of a unit circle is 2 pi, so the radian measure of an angle of 1 full revolution, or 360 degrees, is 2 pi. All right, so if we talk further about this, that means that the degree or the radian conversion, 180 degrees is the same as 1 pi. So if we go back up here and we talk about the conversion between these, I'm going to switch to pen so you can see it. So that means that 180 degrees is pi radians, 360 degrees is 2 pi radians. So that means that if this is 1 pi and this is 2 pi, then this right here must be pi halves. If this is 1 and this is 2, this must be 1.5, but people don't write it as 1.5. They say 3 halves or 3 pi halves because it's in terms of pi. So that's how the radian measurement works. Is it 0 pi? Write that 0 pi. 0 pi, pi halves, pi, 3 pi halves, and then 2 pi radians. So the part about radians that makes people a little bit uncomfortable is you really get in touch with fractions when you're doing your angles in terms of radians. Degrees, you're just big numbers between 0 and 360. Radians, you are talking almost always exclusively in terms of fractions, which is what makes people uncomfortable about radians. So 180 degrees equals pi radians. Radians are usually written in terms of pi, but they don't have to be. So it's just a number. The numbers are small. They're usually between 0 and 6.28, right? That's 2 pi. 3.14 times 2, 6.28. The degree symbol is always written anytime you're in terms of degrees. The word radians is usually omitted. So that means if you do not put a degree symbol, I always say bubble. If you don't put a degree bubble, if you just have a number written, then we automatically assume that your angle is written in terms of radians, because in radians you don't have to write the word. So if you don't put a bubble there, we assume that the number is in terms of radians. All right. 1 radian is the measure of the central angle of a circle that intercepts an arc equal in the length to the radius of the circle. I butchered reading that out loud. I'm sure it didn't make sense. Let me read that again. 1 radian is the measure of the central angle. We know what that is because we studied it. So here's a central angle of a circle that intercepts an arc equal in length to the radius of the circle. So an arc, remember an arc is the outside, so if you were to take an arc that was equal in length to the radius of the circle, that's what a radian is. Okay. Clear as mud, hopefully. All right. So we're going to go ahead and look at conversions, because if these are 2 ways to measure angles, that means that we can convert these measurements back and forth to serve our purposes depending on what the problem is. So they said they want us to change 30 degrees to radians. So I'm going to say 30 degrees, we're going to convert it to radians. So what I'm going to do is I'm going to multiply it by 1. And the 1 that I'm going to multiply is going to look very strange to you guys. So I'm going to multiply by 1. And the 1 I'm going to multiply it by, I'm going to do 180 degrees on the bottom, because what I want to have happen is I want this bubble right here to cancel with this bubble right here. But I want it to have a pi symbol in there because the pi symbol is what's typical for radians. So what I'm going to do is I'm going to put a pi on here. Now the reason that this fraction right here equals 1 is because these 2 in radians and degrees, they're equivalent measurements. These angles represent the exact same thing. So when I take this 30 degrees and I multiply it by pi over 180, I'm essentially multiplying it by 1. So I'm changing what the 30 degrees looks like, but I'm not changing the angle that it represents. Okay, so 30 times pi over 180. Now the way you're going to type this in your calculator is you're going to type 30 times 1 over 180. So we're not going to type the pi in because we don't want a decimal answer. We want to have a fraction that's written in terms of pi. So if we're going to write the pi on our paper, we don't want to type it in our calculator. So I've got 1/6 here, and so now I'm going to stick the pi on top. So we've got 1 pi/6, and most people would just write pi over 6 for that. So that is the angle in radians. Okay, now we're going to do the same thing over here. We've got radians, we're going to convert to degrees, so 3 pi/4. Again, I'm going to multiply it by 1. I want the pi to cancel out because degrees typically don't have a pi in them. They could, in theory they could. Radians do not have, like, I don't know, the copyright on pi. They're not the only angles that are allowed to have pi in the number, but typically radian measurements are the ones that have pi, degree measurements don't, typically. So I don't want to have the pi in the answer because I usually don't, and I do want to have a bubble. So that means that the fraction I'm going to use is 180 over pi. So these are the two options we have. We have pi over 180 and 180 over pi. Those are the two different ways that we can convert back and forth. And so this way of saying, oh, I wanted to cancel the bubble, oh, I wanted to cancel the pi, that's how you choose which fraction to use. So 180 over pi, that equals 1. So I'm multiplying this angle by 1. I'm changing what it looks like, but I'm not changing the angle that it represents. It still represents the same number. So here the pi's are going to cancel out, and now I can just do 3/4 times 180. So I'm going to do 3/4 times 180. I get 135. I got to make sure I have my bubble in there. Ms. Rice, do you care if we draw the bubble, or are you going to mark us down if we don't have the bubble? Absolutely yes, because the bubble matters. Okay, if you don't have a bubble, you have 135 radians, which is just a lot of radians. Okay, next page. Two angles in standard form, in standard position, are called coterminal. If they have the same terminal side. So that means we already drew a perfect example of it. 0 degrees and 360 degrees. They're in the same spot, but 0 is where we started. And then we went around the whole circle and we came back to 360. So they're not the same angle, because with 0 degrees, you hadn't, your angle is like this, right? Your angle is nothing. And 360 degrees, your angle is a full circle. So those are two different angles, but they end in the same spot. Their terminal side is in the same spot. So coterminal have the same terminal side. They're angles with the same terminal side, but they differ only in the number of revolutions they have. So 0 degrees had 0 revolutions, 360 degrees had 1 revolution. In fact, I could go around again and have 720 degrees. So basically what happens with this is you could keep going around the circle and adding 360 degrees and adding 360 degrees. And if you were to draw it, it would end up looking like a spiral. You just have a lot of circles drawn there. So angles that differ in degrees, they differ by 360 degrees, but they're equivalent. So 0 degrees looks like 360 degrees by the terminal side, looks like 720 degrees, but based on their terminal side, they're equivalent. Angles differing in radian measure by multiples of 2 pi are equivalent based on their terminal side. All right, every angle has infinitely many coterminal angles, because you can keep adding a circle. You know, you can keep adding 360 degrees, or you can keep adding 2 pi to a number as many times as you want. So infinitely many. All right, last but not least, we have what is called a reference angle. A reference angle is the acute angle formed by the terminal side of a given angle and the x-axis. Reference angles are always positive and always less than 90 degrees. So what you see here is you see an example of a reference angle drawn in the first quadrant. You see an example of a reference angle drawn in the second quadrant. You see a reference angle drawn in the third quadrant, and an example of a reference angle drawn in the fourth quadrant. And I don't want to do a lot of explanation in the video because it's long enough, so we'll talk about that more in class tomorrow.